Introduction to conic sections, circles and ellipses. Conic sections are actually developed by an ancient mathematician 2,000 years ago from Greece called Apollonius. And what he basically stated was we can get, for the most basic circular and geometric functions, out of conic sections. And I'm going to show you in the next slide how we get those. And what we're looking at here is a cone, and it's actually a right angle cone, meaning that if we take a cone here, I'm going to draw my best possible skills, which are limited here. Here's the bottom of a cone, and a right angle cone, and that's not really good. If I drop the vertex of the cone down to the center radius, which is at the bottom, no matter where I go on the base of that cone to that center radius is a right angle. So this is a right angle cone. And conic sections does a lot for us in terms of developing the equations for the hyperbola, the parabola, the ellipse, and the circle. And this is basically by cutting planes through two sets of cones. And actually, for most of them, with the exception of the hyperbola, you need just one cone. The parabola, if you cut it at an angle right here that cuts through the base, you get a parabola. And depending on that plane that cuts through it is the severity of the parabola. A circle is a horizontal cut through the cone. You look straight down at it, you get a circle. An ellipse is a special kind of circle, or I should actually say circle is a special kind of ellipse. You cut a slight angle, not deep enough as a parabola, but far enough that it's the x-axis and the y-axis are not equivalent in terms of the radiuses. We have two different radiuses. The circle has the same radius. And the only difference is the ellipse is not cut through the base. And then a hyperbola is a vertical cut. And it kind of looks like a parabola, but going opposite directions. And we're going to talk about each one of these over the next couple of days. The equation for a circle is x minus h squared plus y minus k squared equals r squared. And r squared is the radius squared. And again, the radius is from the center point to any point on the circle. Our h is the center point on our x-axis, and our k right here. And our k is the center point for the y component, which is over here too. So if I look at this circle is defined with a center point of 1, 2, that's my h and my k, and a radius of 3. And the equation would simply be written as x minus 1 plus squared plus y minus 2 squared equals 3 squared, or 9. Here's another one. I can simply look at the circle here. My center point is 4 and negative 6. So my equation would be x minus 4 squared, and it's negative 6. So it's y minus k, which is y minus negative 6 or y plus 6 squared. And then when I look at this, it says it equals 48. That's the equation. Remember, that 48 is r squared, the radius squared. And this is really, if you look at this is really just a modification of the Pythagorean theorem. A squared, which would use the trig. A squared plus b squared equals c squared. And we actually do this with trig, with the various angles at 90 degrees right here. Again, it's a terrible 90 degrees, but that's the radius is the same. So, and they're given 48, so the square root of 48 is the radius, which is 6.93. And if you count here, you can see it goes from we can go from on the x-axis 4 to 0 is 4, 5, 6, almost 7, and that's why 6.93. Here's another one. 4, negative 3 is the center point. So that would be, I'm sorry, it's 4, negative 3. So that'd be x minus 4 squared plus y minus negative 3 squared, or y plus 3. And then I look at this, 16 is r squared. And the square root of 16 is 4. And if we look at this, 1, 2, 3, 4. That is the radius. Now we can also write an equation. And this is a little small here. But I can write an equation that has a radius of square root of 13. And the center of the circle is located at negative 9.3, 4.1. So I know my equation is going to be x plus 9.3 squared, or x minus negative 9.3 squared, plus y minus 4.1 squared equals the square root of 13 squared. And square root of 13 squared is 13. Here's another one here. I am located at 5, negative 2 for the center point. So it's going to be x minus 5 squared. Y minus negative 2 squared is y plus 2 squared. And that radius is, let me count here. Let me see how far it is. 1, 2, 3, 4, 5. So it's r squared is radius squared. So it's 25. My equation is x minus 5 squared plus y plus 2 squared equals 25. Now, ellipses are a modification of a circle, and actually a circle is a very special ellipse. The difference is with an ellipse is along the x-axis and y-axis, one of the radiuses is larger than the other. They're not equal, like is in a radius in a circle, where the radius is equal all the way around. In this case, on the horizontal axis, the vertex, which is the major axis, is found to be the larger one. It's longer. You can see it's wider. The covertex is on the minor axis. This is the smaller axis of the ellipse. Now we're going to talk about the focus in a minute. The special thing about the focus, and we'll show you how to find the focus, is the focus is always along the major axis. And whatever this distance is from one focus to a line to the other focus, no matter where, if I start the focus, let's say at a string here, no matter where I went from there to there, not pronounced a straight line, it's the same distance as the first one. Or from there to there. Anywhere along the edge of the ellipse, when I have a string attached to two focuses, it's always the same distance. If this was 1 and this was 7, that's 8. Then and that's 8 total. Well, when I do that, that means this would be, if this was 3, this would be 5. If this was 2, this distance here, this would be 6. And that's the only point we find along the focus. The focus we often use in the real world, such as when we're orbiting satellites, to stay within a geosynchronous orbit. Now, let's look at this. I'm going to define this ellipse here. The major axis is along the x-axis, but we're going to chart it as y equals 2, because right here you can see the longer side is at y equals 2. And what are my vertices? Well, that is where the longest endpoints are of that ellipse. So this would be negative 1, 2, and then this would be 9, 2. So those are my covertices. And what's my major axis radius? Well, I'm just going to go from the center point to one of those sides. And if I go from 2 to, let's see, it's 4 to negative 1. That's 5. Or I could go from 4 to 9. Again, that is 5. Let me erase this work here because I want to talk about the minor axes. And obviously the minor axis is going to be along the smaller one. And that is along where x equals 4 right here. And that's what are the covertices? Well, that's going to be 4. It looks like negative 1/2, and I put negative 0.5 here. And then 4 and 4.5 right here. And the minor axis radius, if I just look at this, this would be look like it's 1, 2, 2.5. Again, the center is at 4, 2. Here's another one. The major axis is the longer one. And this is along, it's going along the vertical axis, but we coordinate it's at x equals -1 right here. And my co-vertices, it looks like I did this mechanically. It's 4.464 here, and -1, and that looks like 7.56. My minor axis is going to be at y equals 4, right there. And that looks like it's -3.94 for this x coordinate and y coordinate, and this looks like it's 1.9, right a little bit below 2, and 0.4. The major axis radius is 1, 2, 3. Let's see, 1, 2. I got 3 point. Nope, that's the minor one. 2.9. It's almost 3, and then the major one is 1, 2, 3, about 3.5. I actually got here 3.536. Now, the equation for ellipse is very similar to a circle. In fact, that's why I said a circle is a modified ellipse. We still have the x minus h squared here, and the y minus k squared here. Now, we got a fractions here. This is a rational function, a squared and b squared. And the a squared is simply the horizontal radius, which would be whatever, it is along the y-axis here, but just remember, it's a horizontal axis, it's going to be x. That's where the x goes, vertical, and then the vertical radius is going to be b. And we squared. And the only difference is between this and a circle, if you actually look at this. Remember that the equation for a circle is x squared. I'm sorry, let me erase that. X minus h squared, because we don't want it at the center. X minus h squared plus y minus k squared. Now you notice here, and it's the ellipse, it always equals 1. Well, let's suppose I had a circle. If I had a circle centered at 4, 3, and a radius of, let's say it's 5. So this equation would be equals r, for originally should be r squared. But and that would be x minus 4 squared plus y minus 3 squared equals 25, or 5 squared. Now, let's suppose I wrote the circle with an ellipse equation. And remember, my A is my horizontal radius, my B is my vertical radius. Well, with a circle, the horizontal and vertical radius are the same. So what's gonna happen if I write this as an ellipse equation? I'm gonna write this, and let's say I said 4, 3, and a radius of 5. X minus 4. Looks like a 9. Sorry about that. X minus 4 squared. And my radius, I said, is 5 squared. So on the horizontal axis, it'd be 25. 5 squared, that's my a squared, plus y minus 3 squared. And my vertical radius is also 25, 5 squared, which is 25. And I said, and I'm writing this as an ellipse, equals 1. Well, if I multiply both sides by 25, put 25 out here, This one, I don't like that fraction 25. And remember, algebra means balance in Phoenician, so I have to, do I do it one side, do the other. Well, what happens here, this 25 cancels that one out and that one out, and I'm left with x minus 4 squared plus y minus 3 squared equals 25. And really, like I said, the circle is a specialized ellipse where the A and B are equivalent. So what ellipse is represented down here? Let's erase this. Like I said, again, I am not the neatest writer with this. I'm not neat in general, but this is really not good. Sorry about this. I hope you can read it. If not, email me. All right, so I'm looking at this here. That last one. I'm looking at this here on the bottom half. And what I've got here, I got my pen working, is y minus 4 squared over 9 plus, I'm sorry, x minus 4 squared over 9 plus y plus 6 squared over 4 equals 1. It always equals 1 in ellipse, and I've shown you why we do that. So that means my center point is going to be at 4 minus 6. And what is my horizontal radius? It's going to be, if 9 is a squared, then square root of 9 is 3. So it's 3, and then my vertical is 2. And if I look at this, I actually drew this in decimals. Here's my 4, negative 6. My major axis is my horizontal axis. And if I go from, let's see, 4, 6, that's 7, from 4 to 7, or from 4 to 1, that is 3. So my radius is 3. And then if I go on the vertical axis, from negative 6 to negative 4 is 2, or from here to here, from negative 6 to negative 8 is distance of 2. So we have defined this circle by just looking at the circle and can look at the equation to determine what our A is, what our B is, our radius is for the major and minor, as well as where it's located. Here's another one. If I look at this, well, x minus h squared over a squared plus y minus k squared over b squared equals 1. And if my h is negative 4 and my k is 3, that means it's going to be located at negative 4 and 3 for my center point right there. And my equation, I'm looking at this 4 and negative 3. And let's see, the radius, the horizontal radius is 5. This distance, I made this right here. And so x minus negative 4 is x plus 4 squared over 25. That's 5 squared. And then my distance on my minor axis, which is also in this case my vertical axis, is 4. And it looks like it goes from negative 4 to, let's see, I'm sorry, negative 3. Or no, it goes, yeah, from 3 to 7, which is 4. So 4 squared is 16. That's located at negative 4, 3. That's our equation. Now, the focus, as I said before, is basically at what point, and they're equidistant from the center, and we can find that equation. The focus is where if I have a line, if I go take a string or any line, this distance to anywhere on the edge of the ellipse, and this distance will remain the same as I move the string around. In fact, I'll go here, and it's only from the focuses. If this was 3 and that was 5, that's 8. If this was 6, then this would be 2. If this was 1, it always equals 8 in this case. That would be 7. This would be 1 and 7. So the focus is when we attach a line going from one point, any point on the ellipse, back to the other focus, that distance does not change at all. And how do we find it? That the focus distance is always from the center. It's f squared equals p squared minus q squared. And that's going to be the major axis minus the minor axis. And we had to find the square root of it. Let's just go back and see. Find the focus of the previous ellipse we were looking at. And here it is right here. Here's the equation. This was 2 slides ago. X plus 4 squared over 25 plus y minus 3 squared over 16 equals 1. Same ellipse. Now, my focus is going to be basically my major axis over my minor axis. And I should let you know the focus is only on the major axis, whether it's horizontal or vertical. It can only be on the major axis. So, f squared, my focus squared, is p squared minus q squared. And my larger one is 25, if it is 5 squared, minus the minor axis, which is my q, and this is actually my b in this case, which is 16. So 5 squared minus 4 squared is 25 minus 16, which is 9. F squared is 9. Focus squared is 9, which means the focus is 3. Now, when I had a focus of 3, that is 3 from the center. We always have 2 focuses on the ellipse. 1, 2, 3. So if my center is negative 4, 3, my first focus is negative 7, 3, and then my second focus is negative 4 plus 3. 1, 2, 3. So it'll be negative 1, 3. But that is simply how we find the focus. It's basically my major axis squared radius minus my minor axis radius squared. That's the focus squared. Get the square root of that, we get our answer. Let's do one more here. Now this is where the major axis is the vertical axis this time. And my center point is 5, negative 2. And the equation for this is going to be, let's see, x minus 5, because it's at 5 here, squared, over y plus 2 is at the minus 2 squared. And then we got to find out what the radius is. Well, the radius on the major axis is going to be 1, let's see, from here, 1, 2, 3, 4, 5, 6, 6.25. I'm sorry. That is the vertical axis. Let me erase that. 6.6 point, what's that? 6 point, no, I'm sorry. What is that? Make sure I'm right here. 6.5. So from here to here is actually 6.5. 6.5 squared is 42.25. And then if I go from the minor axis, 1, 2, 2.5. 2.5 squared is 6.25. So I'm going to take these, my major axis minus my minor axis, 42.25, 6.5 squared minus 2.5 squared, or 42.25 minus 6.25. And lo and behold, and I did this purposely, so it's easy to calculate. My f squared is 36. Square root of that is 6. So my focus is 6. And again, that focus is from the center point along whatever the major axis is. So let's look at this. And if it's 6, well, let's see. My vertical axis is my major axis here. So it starts right here at 5, negative 2. 1, 2, 3, 4, 5, 6. And that puts it negative 8. If I go this way, add 6 to the negative 2. 1, 2, 3, 4, 5, 6. So it's 5 and 4. Again, it's along the major axis, which is at the x coordinate of 5, but I go 6 up and 6 down because my focus length is 6, and that's from the center.